Hello guys, my name is Ashwin and here's the solution. So here's the first question, and we've been given some information. We have the volume of room as 20,000 cubic feet. The inflow of fresh air is about 600 cubic feet per minute, and the outflow of mixed air is also 600 cubic feet per minute. Now we have to find the amount of fresh air at any time t, given that y0 is equal to 0, and also we have to find at after what time 90% of the air in the room will be fresh. So let's try to frame an equation. So let y be the amount of fresh air at any time t. So the rate of change will be equal to y dash, that is dy by dt. And in the question it is given that the rate of change equals the difference between the fresh air inflow rate and the mixed air outflow rate. So using that we can form an equation that y dash is equal to 600 minus 600 by 20,000 into y. So this will be the equation. So further solving this equation, we can write it as y dash is equal to 600 minus 0.03 y, and then y dash is equal to y dash plus 0.03 y is equal to 600. So this is the differential equation, but it is an non-linear homogeneous equation. So we have to compare it with the existing form. So here we have a linear non-homogeneous equation. So we need to compare it with the general form, which is dy by dt plus pty equals qt. So we'll find the values of pt and qt by comparing, and then we'll calculate certain parts. So solution to this ODE is given by y is equal to e raised to minus h c plus integral r e raised to h dt. So we have to calculate the constant h. So first we have px is equal to 0.0, sorry, pt is equal to 0.03, and rt, sorry, qt is equal to 600. So to calculate h, we have this formula: h is equal to integral p dx or p dt is equal to integral 0.03 dt. So we have 0.03 t, that is h. So from this we have the value of e raised to h is e raised to 0.03 t, and e raised to minus h is obviously e raised to minus 0.03 t. So in the above equation we have r is qt, r is equal to qt. So in r, e raised to h is equal to 600 e raised to 0.03 t. So now we'll calculate the general solution. So here we have the general solution: yx is equal to e raised to minus h c plus integral r e raised to h dt. So we found out the values of e raised to minus h and r e raised to h in the last part. So we'll put that here, and now we have to solve the integral. So I've solved a little bit of the equation. So integral 600 e raised to 0.03 t. When we solve the integral, we'll have 600 is the constant, so it will come out, and e raised to x, it will be same e raised to x, and 0.03 will come in the denominator. And when we cancel out, the constant factor becomes 20,000. So finally we have the equation now as e raised to 0.03 t c plus c is the constant of integration plus 20,000 e raised to 0.03 t. So we'll open that now. We have c e raised to minus 0.03 t plus 20,000 e raised to 0.03 t, and that the powers will add up and become 0. So the e raised to power 0 will be 1. So we will only have 20,000 remaining. So this will be the equation. So now we'll have to find the constant of integration. So using the initial condition, we know that y0 is equal to 0. So we'll substitute that into the equation, and we'll have c e raised to minus 0.03 into 0 plus 20,000 is 0. So this becomes e raised to 0 and the whole thing becomes 1. So we'll have only c remaining. So it will be 20,000 plus c is equal to 0. So we have the value of c as minus 20,000. So substituting the value of c in yx, we'll finally have the equation yx as 20,000 minus 20,000 c, 20,000 e raised to minus 0.03 t. So solving further, we have the equation yx is equal to 20,000 1 minus e raised to 0.03 t. So using that we can find the amount for any time t. Now we need to find out at what time there will be 90% fresh air. So for 90% fresh air, the amount of the fresh air will be 90% of the total capacity of the room that we know is 20,000. So that comes out to be 18,000 cubic feet. So substituting 18,000 for y, we have 18,000 is equal to 20,000 1 minus e raised to minus 0.03 t. So put this. So we have 9 is equal to 10 minus 10 e raised to minus 0.03 t, and we'll bring the 10 over here. We have minus 1 is equal to minus 10 e raised to minus 0.03 t, and the minus cancels, and we'll bring the e here on this side. 1 upon e raised to minus 0.03 t is equal to 10, and because this minus, it will go up and become e raised to 0.03 t is equal to 10. So we'll take natural log on both sides. So on taking natural log on both sides, we'll have this will become, either e will get out and we only have 0.03 t, and the value of natural log of 10 is approximately 2.3. So we have t is equal to 2.3 by 0.03, and if we calculate, it comes exactly as 76.666. So we'll approximately, it will be equal to 77 minutes, because we had all the units in cubic feet per minute, so the time will be in minutes only.